In this question, you have a skier launches off a ski jump with a horizontal velocity of 30 meters per second and no vertical velocity component. What are the magnitude of the horizontal and vertical component of her velocity the instant before she lands 2 seconds later? Question has given me horizontal component of velocity. So when the skier jumps off, she moves in this manner, which is an example of a horizontally launched projectile. And the horizontal component of velocity is given to me, the x component. Horizontal means the x component, which is 30 meters per second. Since there is no y component, no vertical component initially, initial y velocity will be 0. My time t is 2 seconds. They want us to find what is horizontal and vertical final component after time t. Now in projectile motion, x component of velocity remains constant. It does not change. So whatever was the value for x velocity in the beginning, the same value will be at every other position. It will not change. So my final x velocity will be equal to the initial x velocity, which is 30 meters per second. Y component on the other hand will change because you have acceleration due to gravity acting along the y-axis. So we can find the y component of velocity using equation of motion. And we'll write Vy equals Vy0 plus a into t. Initial y velocity is 0. If you launch a projectile horizontally, y initial is always 0. Acceleration is negative 9.81 because the motion of projectile along y-axis is similar to free fall motion, and we take a to be equal to g. So a is negative 9.81, time is 2. Y component of velocity will become negative 19.6 meters per second. In the next question, you are practicing throwing darts in your room. You stand 3 meters from the wall on which the board hangs. So this is the figure. The dart leaves your hand with a horizontal velocity at a point 2 meters above the ground. So this is the initial position from which you release the dart. So 2 meters above the ground is your initial y component of position. The dart strikes the board 1.6 meters from the ground. So this is where the dart ends up on the board. So this is my final y component of position. Calculate time of flight, initial speed and velocity of the dart when it hits the board. You are standing 3 meters from the wall. That means the range, the distance along the x-axis, maximum distance along the x-axis, the range of the dart is 3 meters. So we will write the range r to be 3, initial y position 2, final y position 1.65. Initial velocity will be 0 because you are throwing something. Before you throw it, you are holding it, and at that point your initial velocity is 0. Acceleration along y-axis will be acceleration due to gravity, which is negative 9.8. So let's find the time of flight. First part of the question wants me to find time of flight. We use the equation of motion. Again, this is an example of horizontally launched projectile. Horizontally launched projectile means a projectile which has only horizontal velocity in the beginning, initial horizontal velocity, and then later it follows a parabolic path to the ground. So I use equation of motion to find the time of flight. Since we have both y position, initial velocity and acceleration, I'm going to use this equation. Y final is 1.65, y initial is 2, initial y velocity is 0, a is negative 9.81 t squared. We rearrange the terms, we move 2 to the other side. Or you can also use shift solve. You can rearrange the term to find the value of t, or you can use shift solve to get t. And I find my time of flight to be 0.27 seconds. After we find the time of flight, I want to find the initial speed of the dart. The initial speed. So initial speed is the speed with which it was released. Now when we release the dart, in the first part of the question we took y component 0. Y component is 0 because initially there is no y component of velocity, but we are releasing it with only x component. So when I'm finding initial speed, I'm finding what is initial x velocity, as the y velocity is 0 initially. So initial speed of the dart, which is the x component of velocity, how do we find it? Question has given me the value for range. Now range is nothing but the distance the dart travels along x-axis. And we can always find distance by multiplying velocity with time, the x component of velocity. And I can find this distance by multiplying velocity with time because along the x-axis there is no acceleration. In projectile motion, along x-axis the acceleration is 0. And if acceleration is 0, I can use the basic rule between speed, distance and time to find my range. So distance d will be velocity into time, and I can find the velocity by dividing distance with time. The total distance that we traveled along the x-axis is already given to us, which is the range. So I will write my range equals x velocity into time right over here. Yes, right over here. So we rearrange this, we write Vx equals r over t, substitute the value of range and the time we just calculated, and you get the x component of velocity to be 11.1 meter per second. So this was the initial x component, Vx 0, and initial y component will be 0. Vx initial will be 11.1, Vy initial will be 0 for a horizontally launched projectile. Final part of the question wants you to find velocity of the dart when it hits the board. When the question asks you to find just the velocity, it means it is asking you to find the final velocity when it hits the board. Now to find final velocity, first you need to find the components. You need to find the x component of final velocity. You need to find y component of final velocity. Then we can use Pythagorean theorem to find the final v, combined final v. In projectile motion, x component of velocity does not change. So whatever value x component had initially, the same will be the final value for x. So Vx final equals Vx initial, which is 11.1 meter per second. Y component we will find using equation of motion. Vy equals Vy0 plus a into t. Y0 initial is 0. Y initial is 0 because when a projectile is launched horizontally, y component of velocity is 0. A is negative 9.81, t is 0.27, which we found in the first part. When we solve, we get the final y velocity to be negative 2.65 meter per second. Negative again because it is going down. Resultant v, final resultant v will be square root vx squared plus y squared. Put the values. If you're taking square of a negative value, make sure you put the negative sign inside the brackets. When you solve this, you get the final velocity as 11.4 meter per second. You can find the angle by taking tan inverse y over x. So this completes the question. Please remember, in any horizontally launched projectile, you can solve the question using equations of motion. Y component, initial y component for horizontally launched projectile is always 0. There will be some x component of velocity. Either they give it to you or they ask you to find it. But this value of x will not change. It will remain the same throughout. In the next question, You have an object fired at an angle 35 degrees above the horizontal, and it takes 1.50 seconds to travel the last 15 meters of its vertical distance and last 10 meters of its horizontal distance. With what speed was the object launched? See, the problem does not specify initial and final elevation of the object are the same. Okay. Now question has given me last 15 meters of vertical distance and last 10 meters of horizontal distance. So it's like this. If it is launched, maybe the last 10 meters of horizontal distance looks something like this. This is the last 10 meters and this is the last 15 meters of vertical distance. Question wants me to find with what speed was it launched. So what is the initial velocity, the combined initial velocity V0? I can find x component of velocity using the equation for x-axis. And why I'm emphasizing on using equation for x-axis is because along x-axis there is no acceleration. Acceleration along x-axis is equal to 0. So I know x component of velocity will not be changing. It is constant. So I can take any point on the x-axis as my distance, and when I divide it by the time given, I can find out what is my x component of velocity. So I will take my range, distance along x-axis as 10 meters. That is my delta x. I will use delta x to find what is x component of velocity. So velocity v is distance divided by time or displacement divided by time. So I cover the last 10 meters in 1.5 seconds. So I will write 10 divided by 1.5, which is 6.67 meters per second. And the reason I'm using x component, because then I don't need to know my position, my initial position. I don't need to know the acceleration, although along y-axis we know acceleration is negative 9.81, but it makes it more easier to solve it this way as x component of velocity will not change. So 6.67 meters per second is the value of Vx. Now I know my velocity v, initial velocity v, is been divided into two parts. One along the x-axis, which you get as v cosine theta. One along y-axis, which is v sine theta. I know the x component of velocity. I will use this equation to calculate what is my v. So we know Vx is v cosine theta. So divide by cosine theta on both sides, and you will get your v to be equal to 6.67 divided by cosine 35, which is 8.14. So you could have done this by first calculating y component of velocity also, but I find it much easier to do with x component as there's no acceleration here, and x component of velocity will be the same no matter which region you find the velocity from. So final initial velocity in this situation is 8.14 meters per second.